All right, welcome back everyone to another deep dive. Today on The Explainer, we're bringing together two absolute powerhouses of operational excellence, root cause analysis and data analytics. You know, we all face bottlenecks, defects, and delays in our workflows, but how often are we actually solving the real problem, and how often are we just slapping a Band-Aid on it? Today, we're going to learn how to transform from, well, reactive troubleshooters into systematic, data-driven detectives. We're going to dig up the actual roots of our business problems.
Think about your organization kind of like a thriving garden. The principle here is simple but incredibly profound. When a weed pops up, snapping off the leaves might make things look better temporarily, but the weed will inevitably grow back. And that is exactly what happens when we treat surface-level symptoms instead of finding the concrete evidence needed to eliminate the actual root of a problem. To stop the weed from coming back, you can't just dig blindly. You've got to put on your detective hat, use the right tools, and completely pull that weed out by the roots.
Okay, let's map out our investigative journey today. We're covering 1. The problem-solving mindset. 2. Measuring variation in processes. 3. Visualizing evidence and causes. 4. The root cause taxonomy. And 5. Ensuring the fix stays fixed.
Starting right off with Section 1, the problem-solving mindset, preparing the investigator. Before we even think about opening a single spreadsheet or plotting a data point, we absolutely have to shift how we think about solving business problems. Seriously, if your mindset is flawed, your data analytics will literally just lead you to the wrong conclusion, only faster. So here are the core principles for any root cause analysis investigation. First, you got to look beyond the surface. Remember, symptoms are just signals, not the solution. Next, beware the silver bullet myth. Rarely is there just one single magical fix out there. Problems usually have multiple contributing roots. Third, and this is a really big one, blame processes, not people. Human error is almost always a process failure in disguise. We also must rigidly rely on concrete data over our gut opinions. Our analysis has to actually empower action for our stakeholders. And finally, we have to think long-term about true prevention.
So, what does this all mean? It means you need to fundamentally shift your focus. Stop treating symptoms and start uncovering the underlying problems. Informal, intuitive approaches fail because human nature pushes us to settle on an apparent cause way too quickly. But structured, data-driven root cause analysis, that improves process stability, radically reduces waste, and ensures continuous improvement.
Moving right along to Section 2, measuring variation in processes, the vital signs.
Once our mindset is locked in, data analytics acts as a vital diagnostic tool. It reveals how a process actually performs in the real world rather than how we just hope it performs. Now, to understand process performance, we have to understand variation, and the absolute gold standard here is standard deviation. A lot of people just look at the range, the difference between the highest and lowest values, but standard deviation is vastly superior because it considers every single item in the entire dataset. It doesn't just look at the extremes, it looks at the whole picture to tell us exactly how consistent or inconsistent our process truly is.
And let's look at a mini story that brilliantly illustrates why this matters so much. We'll call this the call center dilemma. Imagine two customer service centers. Center A has a mean wait time of 12 minutes and a standard deviation of 2 minutes. Center B also has a mean wait time of exactly 12 minutes. Now, if you only looked at the average, you'd probably think these two centers are performing identically. But look closely at Center B's standard deviation.
It's 6 minutes. Focus intensely on that number for a second, because Center B has a massive 6-minute standard deviation. The customer experience is wildly unpredictable. That variation directly causes severe bottlenecks. It means that periodically, a huge chunk of customers are waiting much, much longer than 12 minutes to speak to a representative. Identical averages, but drastically different realities. That is exactly why variation is the silent killer of customer satisfaction. Next up, Section 3, visualizing evidence and causes, mapping the crime scene. Now, what's really interesting here is how we turn all that abstract statistical data into undeniable visual evidence. Because let's face it, unless data supports your presumed root cause, absolutely nobody is going to buy into your findings. We have to map the crime scene so we stop relying on intuition. Our first visual tool is designed to find the vital few issues. Look, in any complex system, there are a million things going slightly wrong. But if you try to fix all of them, you're just going to exhaust your team and accomplish nothing. We want to prevent wasted effort on minor contributors and focus our energy on the few real culprits that are causing the vast majority of the pain.
Enter the Pareto chart. This is a real game changer. Here's your step-by-step masterclass on building one. Step 1, categorize and count the occurrences of a problem. Step 2, calculate the cumulative sum by adding those counts together consecutively. Step 3, calculate the cumulative percent by dividing that sum by the total number of issues. And Step 4, plot a bar chart for the quantities and overlay a line chart for the cumulative percent. It's incredibly straightforward, but wildly powerful.
Let's actually see this math in action. Out of nearly 700 total issues, just the first category, wrong item sent, accounts for over 300 of them. When we add the second category, damaged packaging, our cumulative sum jumps to 553. If we look at the cumulative percent, we see that just these two categories alone account for a massive 79% of all our issues. No way, right? Instead of chasing down every single minor complaint, you now know exactly where to strike.
Okay, so once you know what the main problem is, you need to brainstorm the causes. For that, we use a fishbone diagram. But creating these completely from scratch can lead to blind spots. So we use structured prompts. By systematically interrogating methods, equipment, materials, people, environment, and management, you prevent premature conclusions. You literally force your team to look at every plausible suspect, not just the obvious ones.
Which brings us to Section 4, the root cause taxonomy. Knowing where to look.
You know, even the best detectives will miss vital clues if they only look in the places they're most familiar with. To prevent an incomplete analysis, we're going to rely on a highly credible source. We can adapt the U.S. Department of Energy's root cause taxonomy. This framework systematically scans the entire environment, ensuring nothing slips through the cracks. Let's break down a few of the primary areas you absolutely must investigate.
First up is design. You gotta ask yourself, is the very setup of our process the true culprit? Sometimes a process functions exactly as designed, but the design itself is inherently flawed from the start. You also have to look out for silo effects. Instances where different process steps were designed in isolation, resulting in integrated systems that fundamentally fail to communicate with each other.
Next, examine equipment and material. Keep in mind that tools, materials, and information flows that worked perfectly 5 years ago might no longer be appropriate today. Outdated software or broken information handoffs can act like those hidden weeds we talked about, silently choking your garden and driving poor performance without anyone even noticing. And then there's human performance and management. This requires a massive mindset shift. The Department of Energy's framework recognizes that human error is usually an effect, not a root cause. Individual intent rarely causes catastrophic failure. Rather, management decisions, poor communications, and inadequate training create the very conditions that make human error inevitable. Think about it. If you fire the person without fixing the environment, the next person will make the exact same mistake, probably by next Tuesday. And finally, Section 5, ensuring the fix stays fixed, the permanent cure. So the crucial point here is this. Just because you found the root cause and implemented a fix today doesn't mean the problem is solved forever. Sustainable improvement requires true prevention, not repeated firefighting. A fundamental truth of operational excellence is that an exhausting cycle of daily firefighting is a blaring siren of a broken system. You want the sustainable peace of mind that comes from implementing true prevention methods. Your job just isn't finished when the new policy is announced.
To get and maintain that peace of mind, you need what we call continuous vigilance tools. You must carefully monitor the process by periodically sampling the output. You should be plotting those results on quality control charts to ensure that standard deviation isn't creeping back up. And importantly, if your root cause was tied to management issues, like training or communication shortfalls, then periodic management audits are absolutely mandatory to ensure ongoing compliance.
We've covered a ton of ground today, from shifting our mental models to utilizing standard deviation, visual evidence, and taxonomy to pull the real weeds out of our businesses. So I'll leave you with this final thought to apply to your own work today. Between the Pareto chart to find your vital few or the Fishbone diagram to systematically hunt down causes, which will you use first to tackle your bottlenecks? Grab your tools, dig deep, and go solve some problems. Thanks for joining me on this explainer, and I'll catch you on the next one.